Good evening, students. At the outset, let me wish all of you a happy National Science Day. As you know, we celebrate National Science Day on the occasion of birthday of Sir C.V. Raman. So greetings to all. I would just like to start with a small quote of Sir C.V. Raman. Curiosity and courage. There is nothing intrinsically inferior to the quality of the Indian mind when compared to that of a Teuton or an Anglo-Saxon. Rather, what inhibits us is a lack of a certain courage that would allow us to explore unusual avenues. Sir C.V. Raman. Okay, so we now proceed to the next part of the lecture. So last time we were talking about scientific misconducts, where we had discussed fabrication, falsification, and plagiarism. And at the end of the lecture, I found some questions which I thought I must include some more slides on plagiarism to explain more clearly what this whole thing is about. So I'll continue with plagiarism a little bit. Yeah. So you go back to the UGC Gazette on Academic Integrity, which was published in July 2018, where was defined plagiarism has been defined as a practice of taking someone else's work or idea and passing them as one's own. So in this Gazette, you will also find that UGC has given very clear guidelines on how one should go about in curbing plagiarism, and they have assigned some responsibilities to the higher education institution, that is either it's a university or a research institution or an organization. So there are several such instances of, the guidelines which have been laid out on how to curb plagiarism. So first of all, of course, one should implement a technology-based mechanism using certain softwares which are available to ensure that the documents which usually emanate from universities like thesis, dissertations, publications, etc., are free from plagiarism at the time of submission itself. So likewise, there are several such guidelines, especially for students, for which most of you it's relevant now, that a student submitting a thesis, dissertation, or any such document shall submit an undertaking indicating that the document has been prepared by him or her, and that the document is his or her original work and free of any plagiarism. And of course, this has to be checked by the concerned section or the department in the institution. And also, the university or institution must develop a policy on plagiarism and get it approved by the relevant statutory bodies. For example, here it would be HBNI, or probably in a university, it could be UGC itself. So then this approved policy or guidelines should be placed on the homepage of the institute. Then at the time of submission of thesis, every supervisor must submit a certificate indicating the work done by the student under him and indicating that it is plagiarism free. And it goes on with some more conditions like Shodh Ganga e-repository, where all theses which are submitted in Indian universities are a part of this Shodh Ganga e-repository. So if you wish, you can go and find even my thesis on this Shodh Ganga e-repository. And so likewise, there are other guidelines for detection, reporting, and handling of plagiarism. For this purpose, UGC has advised that there should be two bodies for every institution. One is called a Departmental Academic Integrity Panel, and a higher body which is called the Institutional Academic Integrity Panel. So the first step, the first stage, whenever anyone comes across a plagiarism, if you are affected by plagiarism or something like that, or you notice a plagiarism, first thing to do, and if it concerns you or your department, first thing to do is to approach the departmental academic integrity panel, which will have a composition which is again prescribed, and they will send the recommendations to the institutional academic panel, and they will finally go over the whole thing and then recommend the and then advise the correct action. So that's how UGC has laid out some guidelines, and it is now expected that every institution under the UGC is expected to follow these guidelines strictly. So I would like to illustrate one or two cases of plagiarism in detail. The first case is that in 2009, there was a paper which was published by M. Kidwai et al. In the Indian Journal of Chemistry on some chemistry subject, one-pot synthesis of phenolanes. Then later in 2012 July, there was a paper which appeared in the Journal of Chemical Sciences by A. Rajendran et al. Again on one-pot synthesis of substituted phenolanes. Then the very next year, there was a complaint which was received by the editor of the second journal, Journal of Chemical Sciences, JCS, that the later paper is actually a plagiarized version of the earlier paper which appeared in 2009. Then, of course, the whole action started. There was a committee which was constituted by the journal to look into this, at that time, so-called allegation that this has been plagiarized. So we'll see what exactly has been done. So this was the first paper which appeared in 2009 in Indian Journal of Chemistry. And this was by Mazahir Kidwai et al. And what I did was I took both these papers and ran it through software which is freely available on the internet just to see what are the similarities between the two papers. So now we see this is the first paper, and then this is the second paper which was which appeared in 2012 by Rajendran et al. In Journal of Chemical Sciences. Now you can see the similarities here. For example, here you can notice here, for example, excellent yields with high selectivity. For many years, the synthesis of phenolene and its derivative has been of considerable interest. Excellent yields with high selectivity. For many years, the synthesis of phenolene and its derivatives has been of considerable interest, etc. And then it goes on. Then you can see that you can see ahead part of the continuing effort towards the expeditious synthesis of biodynamic heterocycles. Again, here you can see that as part of the continuing effort towards the expeditious synthesis of biodynamic heterocycles, the possibilities of developing a novel, efficient method, the exactly same word to word. So you see, the person who was so lazy that he didn't even bother to even paraphrase the relevant portions and simply copied it ditto, okay, word to word, sentence to sentence, and paragraph to paragraph. So this is such an example where so many, you can see that this was almost a 40% exact match with the earlier paper. So you can see everything here, for example, towards the development of new synthetic methods. It is wished to report herein. Here he writes, we report here a novel and efficient procedure, for the synthesis of phenolene, for the synthesis of phenolene. So you can see that it was so blatant that there was absolutely no other route except to penalize the person who wrote the second paper. And you can see that the editor of the journal finally issued a retraction. Okay, there's some more, you can see the person even copied the tables. Okay, these are the tables in the first paper which are copied absolutely ditto without any change in even the values, times and yields and everything is same. Okay. So, and some more of that similarities. Okay. So, in May 2013, the editor of the journal published a retraction notice in which he clearly says that instance of plagiarism and withdrawal of published article. So they received a complaint from an alert reader. We don't know who that person was. So he says that this is a plagiarized version of an earlier article published in the Indian Journal of Chemistry. The results and discussion part of this paper contain exactly the same sentences, the same tables of results, with the same yields as those of the article published in 2009. It's only the catalyst INCL3 was changed to some other catalyst, and the bibliographic references from 2 to 6 were also the same. Editor has ascertained from the corresponding author, Rajendran, there has been indeed a clear case of plagiarism, and the author has requested the article be withdrawn from the journal. So it is as blatant as that, and I don't know, of course, how this person has been actually penalized. In now, of course, UGC has laid down very clear guidelines on how and what should be the penalty in different cases. This I have already discussed with you in my earlier lecture. There was another very famous case, again from India. I suppose many of you are already aware of this particular case. This is of Dr. B.S. Rajput from Kumaon University. And at the time when this happened, he was actually the vice chancellor of the university. So they published a paper in the journal Europhysics Letters. Okay. This is the title of the paper, and the authors are S.C. Joshi, who was a student, and B.S. Rajput. And this was published in 2002. Then what happened was that immediately another faculty in the same department raised a red flag and then indicated that this is actually a plagiarized version of an earlier paper which appeared in 1996. Then what happened was, since this person was a fairly powerful person at that point of time, he was the vice chancellor, he saw to it that the person who raised the red flag was suspended from the department. But then, fortunately, there were several physicists, theoretical high-energy physicists in the country, as well as from abroad. There were several, one or two even Nobel laureates in that, who wrote to President of India at that time, Professor Abdul Kalam, that this kind of incidents should not occur. It has happened, and it should not occur, and action should be taken. Then only there was a committee which was constituted, and then the committee finally declared that this is actually a plagiarized paper, and then submitted a report. And till that time, even this person, Rajput, he vehemently refused to agree that he was a part of the plagiarization process. He put the whole blame on the student, and he said that he didn't even know that the student had uploaded the paper and got it published. So of course, this is just like saying something after the horse has bolted. So, so finally, the report was submitted, and he was found guilty. After which, of course, he resigned from his position as the vice chancellor. So the committee presented a report in February 2003, upholding all the plagiarism charges. And this is the retraction notice given by the editor of the journal. So he has written very clearly that apart from some introductory review material, the first hour discussion, the text of the paper has been copied literally from Professor Kalosh's article. And the journal apologizes to Professor Kalosh and regrets that this has not been noticed during the reference process. So this was the note given by the editor of that Europhysics journal. So these are the two cases which I wanted to highlight and show you how the process goes on when a case of plagiarism has been detected. But this is a very ideal situation. Again, I must emphasize here that whenever there is a case of a foreign author who is plagiarizing an Indian author's publication, the situation may not be so nice. Normally, again, there's a tendency for journals internationally to side with people from the West. And if an Indian can get a full closure, I guess he will be quite lucky. So I had already indicated that in my last lecture, this is a repeat slide, that a complete retraction of a plagiarized paper will indicate a full closure for the author whose work or idea has been plagiarized. But sometimes there is only an erratum or an apology or a correction, which not many people would even bother to notice. Okay? Unless there is some way that this correction or an apology is linked with that main paper which is plagiarized the content. So in such a situation, in the Indian context, who will protect our Indian victims of plagiarism, especially concerning students? Till recently, as you know, there was absolutely no statutory body to deal with cases like plagiarism research in India, unlike the Office of Research Integrity, which has been there in the United States for a pretty long time. So like the cases which I had shown earlier, for example, the Rajput case, all these were dealt on an ad hoc basis. And again, they were again mostly driven by the public and media outcry that such and such a thing has happened. So it is expected that with the establishment of this UGC care, which I talked about in my first lecture, is expected to fulfill this objective by acting like a watchdog to provide defense mechanisms to victims of plagiarism in India. So let us see how this turns out in the near future. So especially when you're students, when you're a student and you have an out-of-the-box idea or a out-of-the-box thinking on certain problem, you can be even a path breaker. So if you're doing path-breaking research, then one must take really special care to see to it that this particular idea or knowledge which you have generated is properly disseminated and published as early as possible. Now I use both the words publish or disseminate. See, when you say publish, it involves a certain detailed, well-drawn procedure wherein you submit a manuscript to a journal, and the journal, after the editor decides that it can be refereed, he will send it to the referees. Referees will have their own comments, they will take their time, and then you will have to reply to those comments, and then finally it may or may not be accepted to be published. There are other ways of disseminating your results, and that is, as I said in one of my lectures earlier, you can use the system of this facility of archives. So we have condensed matter archives, we have bio archives, we have astrophysics archives. So almost in biomedical archives, in almost every field of research, we have an archive site where you can upload the preprints. And these uploads are taken as if that they give you a stamp of priority or a date stamp on your idea and research. Just to illustrate what can happen, I'll give you two examples. One was a very recent experience, that is water on the moon. So water on the moon was actually, there were quite a few people who were trying to find out evidence for water on the moon. And our own Indian Space Research Organization, ISRO, was one of them. NASA was another. And there was quite a big race to find out whether there is water on the moon. And of course, NASA had very high technology. They had already designed a robotic machine which could land on the moon. They called it the moon rover or something. And it can take a sample from the surface of the moon, analyze it, etc., and send the results back to Earth. ISRO also designed a probe, which was called the Chandrayaan-1. And as you all know, the Chandrayaan-1, there was a probe which was called a crash probe. So this, of course, at that time, we did not have the technology to design a rover on the moon. So we designed, again, you can see the out-of-the-box thinking which went into the design of this machine. They designed a crash probe, which will crash onto the surface of the moon. And in the process, there were 3 instruments in that crash probe, which will measure 3 different properties. And one of which was to find out whether there's water on the moon. And this was a probe called the Chandra High Altitudinal Chemical Explorer or something like that, CHASE. So that instrument was called CHASE. So this instrument, in fact, actually detected the water on the moon through its whatever the methodology it was incorporating to that. Was a very novel methodology. And in fact, the person who designed it happens to be a friend of mine. And so he very vividly, he even talks about this in various lectures and public fora. So this machine did detect water on the moon. But then what happened in September 2009, NASA came out with a publication in the journal Science that they have found evidence for water on the moon. Then on the same day, ISRO had a public press conference in which they said that they also found water on the moon 3 months ago. So the question which was asked is, what have you been doing since the last 3 months? There was no answer. Okay. The problem was that the people in charge of the whole research mission, they wanted to publish it in a very big journal. So they first sent their results paper to Science, which rejected the manuscript. Then they sent it to Nature, which again rejected the manuscript. Ultimately, they finally published it in some other astrophysics or planetary physics journal. But by the time NASA had already published this in journal Science. So this was a very clear case where we totally missed the bus. A simple thing would have been that the results could have been uploaded on the astrophysics archives. Okay, that would have given them a stamp of approval or stamp that the results have been already put on the public domain. And they would have, in fact, received the credit if they had only uploaded their results in an archive website, or they could have even uploaded the results in a journal for which probably there was no such stringent refereeing processes. Maybe they could have uploaded in an Indian journal, Current Science or Pramana, for example. See, this was such an important finding that it would not have mattered at all in which journal it would have been published. Even if it had been published in Pramana, it would have been fantastic. But they didn't do that, and they simply missed the bus. The other example was that of high-DC superconductors. As you know, Bednorz and Muller, they were given the Nobel Prize for this discovery. So this happened in 1986. And in 1986, when they knew that they were onto something very big, but they also knew that their research methodology had some issues, and they realized that if they sent such a manuscript to a very big journal, say like Nature or whatever, or maybe even Physical Review, etc., they realized that probably they will not be able to get through because they had certain inherent problems with the manuscript. But the result was clearly there. But they were not so confident that it will be accepted by the big journals. So they did the next possible thing. They simply published it in the journal Zeitschrift für Physik, which was at that time a local journal in Germany. not a very significant journal. That particular journal became significant only after this paper was published and people knew the importance of this paper. So they were very quick. They immediately published the results in a very nondescript journal. And now, rest is history. They have been awarded the Nobel Prize. So, dear students, I suggest that in case if you are very sure that you are onto something big, don't wait to get it published in a big journal, etc. Try to disseminate it as soon as possible in whichever way you can, so that you will have a stamp that yes, you were the first person to publish this particular result. Okay, moving on. How does this plagiarism check thing work? So this was one of my own paper, my student's paper, which I ran through a software called Urkund, and you can see that this gives a certain flags. For example, these orange flags show that the text has been repeated through as compared to some other existing literature work in the literature. So what did it pick up? Actually, the actual percentage, it was 8% of similarity. And where did this 8% similarity come from? Like my affiliation, which will be same in all the journals. Then a lot of references. A lot of references, of course, will appear in many other journals also. And so this is not a real plagiarism. Okay, this is basically, see, what is the software doing? It is simply trying to compare, okay, text and looking for similarity in text. It has an algorithm to do this. But it doesn't have a mind of its own. Now, to really see whether a manuscript is plagiarized or not, one has to apply some mind to it. Okay, so unless you do that, you cannot really say that whether this particular manuscript is a plagiarized version or not. So someone asked this question earlier that which is the best software. So also now you need to, whenever a PhD thesis is submitted, you have to give a self-plagiarism exclusion certificate from the supervisor, indicating that which are your own papers from which you could have drawn in your thesis, for example. So you have to attribute properly that this work has been published in such a journal. So, so which software is best, etc.? There's no such software. In fact, there was an article which was published in 2019 in Nature. It's called the World View. Plagiarism detectors are a crutch as well as a problem. Okay. So what the author says is that I have been testing this detection software for the past 15 years. The results are often hard to interpret, difficult to navigate, and sometimes just wrong. Many systems report false positives for common phrases, long names of institutions, or even reference information. Software also produces false negatives. The system might fail to find plagiarism if the source or the plagiarized text has not been digitized, contains spelling errors, or is otherwise. So finally, she says, software cannot determine plagiarism. It can only point to some cases of matching text. The systems can be useful for flagging up problems, but not for discriminating between originality and plagiarism. So this decision must be taken by a human being. Okay. So the most important method is for finding plagiarism is reading a text, studying the references for inconsistencies, etc. Okay. So again, as I said, there's no such thing as the best software for plagiarism detection. So one has to apply mind to it and then decide whether a particular work is a plagiarized work or not. Okay, now we move on to that completes my this section on plagiarism. So we move on to the next point, that is redundant publications. So what are these redundant publications? Okay, so redundant publication occurs when two or more papers without full cross-reference share the same hypothesis, data, discussion points, or conclusions. This is as per the Koch guidelines. And then what are the criteria for redundant publication? You can see that the hypothesis is similar, similar sample sizes. When I say sample sizes, it could be even the number of, say, human beings which are which are taking part in a trial, for example. Then identical or almost identical methodology, research methodology. You have very similar results and at least one author in common in both the manuscripts. And finally, no new information or new information of little relevance. So these are the various criteria on which you decide whether a publication is redundant or not. So again, it is said that redundant publications, they jeopardize the integrity of scientific literature, they overweigh the relative importance of published findings and distort the academic record of the authors. So in redundant publications, you have different types. One is what is called a duplicate publications. So a duplicate publication is a kind of a self-plagiarization. And this would be fairly similar to an article which was published previously by the same author or authors without any full cross references. Or it can happen that you have written a manuscript, made 2 copies of it and sent it to 2 different journals at the same time. Or you could have also combined different earlier works, several earlier works of your own into one work and pass it off as a new work. Or you can also work on different samples that give very exactly the same results. So these are types of duplicate publications. There's another thing called salami slicing. So what is salami slicing? You might wonder. See, salami is something, it's a European dish actually, where this is some dish like this, where you cut slices, fine slices, and then serve them for eating. So it's not very common in our country at all. So instead of salami slicing, you can almost say even kakadi slicing. Kakadi slicing also is very similar in my opinion. Okay. So what is this salami slicing? So this is the process of deriving several partial publications from a single source of study. And this again would be quite substantially similar to an article which is published by the same authors. Then, so these redundant articles actually constitute a fairly unethical practice, since they really waste time of the editors, waste time of the reviewers, and they also give a false impression, or they bloat up the author's CV. So then why do people indulge in such redundant publications? So if you see, there are various reasons given by the authors why they have done it. So one person says, one set of authors says, we did not read the instructions. So they are quite glib excuses. We wanted to reach a different audience. Okay. Another set says, our failure to cross-reference the article was a simple oversight. Or some people say, we perceive the overlap to be much less than what the reviewer or the editor thinks, as if that he is superior to the reviewer or editor as far as the publishing of a manuscript is concerned, the journal. We now see that we broke the rules, but this was never our intention. So all these are absolutely glib excuses and nothing more than that. And so what could be the problems which are caused by these duplicate publications? This I have already said, use of editorial resources, the time which goes into that. You know, journals have limited number of pages, and then you are using up those pages where at that stage some other truly original article could have been published. Then again, you have to publish a declaration that this is a duplicate article or it has to be retracted. So that again takes space. And then the readers, who are the audience for your manuscript, okay, for your paper, they get deceived. Okay. Like they have a limited time for reading, and then you're presenting a study of something which is presented as an original idea, okay. And then the ethics part itself. In fact, whenever you submit a manuscript, you actually sign a declaration that the article has not been published previously. You're in fact breaking that declaration. And then aspects concerning copyright. See, you could have published the article in some other journal, previous article. So it has a copyright already. So you're breaking that copyright. Then again, finally, scientifically, a qualitative distortion. of the evidence. So the information is repeated, you give a spin on that, and then you have a perception that scientific evidence is really great. Then there's also a quantitative distortion. Okay, the problems in meta-analysis. Okay, because whenever you publish a paper in a manuscript, you have what is called a meta-analysis. It gives you an idea about how many people have read your paper, what are the other statistics on how many times it has been downloaded. That gives an indication of how good your research is. So you can also even achieve promotions which are inherently wrong at the expense of some other person who was more true to his or more ethical in his scientific approach. So these redundant publications, basically the foundation of scientific publication is based on truth, honesty, and credibility. Originality is the key factor in scientific progress, and if the authors cannot assure this, then one develops a mistrust towards the content of the article. The ultimate responsibility for an integrity of this publication rests on the shoulders of the authors. In the larger interest of mankind, these aberrations must be dealt with firmly and immediately. Okay, so now I move on to the next portion, which is selective reporting and data misrepresentation. So, selective reporting. See, the root of the problem is that everyone wants good data. There's nobody who likes bad data. Okay? So, this problem of bad data is always present. There cannot be any scientific research activity without failure. There will have to be bad data, negative data, which no one likes. But then no one acknowledges that, yes, we have a lot of bad data. Yes, we have some negative data. Nobody acknowledges. This is like this proverbial elephant in the room. So then, who does not like good data, or who doesn't want good data? Everyone wants it. Okay? So even if it means that you push down a bad or negative data, or you don't report it at all, everyone would love to have good data. Okay? So this kind of selective reporting basically is really the cause of what is called a replicability problem in fields like biomedical and life sciences. So let's see how this actually works. So let us take an example of a biomedical or a biomedical study. Okay, so how can actually things can go wrong? So as I said, everyone likes positive results. Why? Because you get very good high impact publications. And when you have high impact publications, you get a lot of citations, and you may also get some media attention. And all these three will combine to get you grants or a promotion, etc. Okay. But then the problem is, how are these positive results generated? Okay. That is because if you have questionable research practices or you indulge in scientific misconduct, you can also end up in positive results. Sometimes it could also be driven by some personal biases or personal interests, or it could also be driven by certain sponsor interests. Okay, so ultimately you get a whole set of positive results which are inherently false. Okay, and these are going to end up in publications, citations, etc., and grants, actually all working on the premise of a false positive result. So let us see an example how this works. So these represent here, for example, this column here of dots, they represent about just over 100 trials of a antidepressant drug which has been just synthesized by a company. So when I say trials, means each dot represents a trial. That means it is done on a certain group of usually human beings who are given this drug, and usually you have some say 100 sample size, that is 100 humans in the taking part in the trial. Then half of them will be given the actual drug, and half of them will be given a placebo. So they won't know what they are taking. So then you are supposed to analyze the results. So that's what each point represents. There are 105 trials of a antidepressant drug. Now, out of this, you can see that there are about 53 positive results and 52 negative results of this trial, of this 105 trials. But when it came to the first publication, it was observed that 52 of the 53 positive outcomes were published, whereas only about 25 of the negative outcomes got published. So here it's a clear bias already saying that we don't want to see negative results. Okay. Then out of this 25 negative results, there was further publications down the line, out of which this 10 negative trials out of this 25, they were sort of again selectively reported in the sense that they did some falsification or things like that, polishing these things, glossing over problems and all those things, and then converting 10 negative trials into positive trials. Okay. So this is called outcome reporting bias. So now you can see that out of the original 52 or 52 positive, you have now increased by 10 more, and then the number of negatives reduces even further. Then finally, then after that, you put a spin on these results. Okay, so you tone down this negativity further and increase the positivity. How do you do that? They are sort of in between. You say that this result showed a trend towards a positive side, etc. So we must take it and all these things. So you again take those and turn them into partially positive. And finally, after these are published, then you have what are called citations. A lot of people cite these works. So people tend to cite positive results rather than negative results. So that again, they give positive results, get more citations, at least 3 to 4 times more than the negative results. So that increases their relevance. You can see that the size of the positive results is shown as increased because we're getting more citations. So there is a citation bias. So now a person who looks at this part of the whole picture will never realize that there's something originally which existed like this. Okay, so this is something like calling it making negative results invisible and then converting them into everything positive. So this is how you can actually do a selective reporting and then increase the number of positive results we want and also increase the number of publications. Then we have what is called the data misinterpretation. So what does this mean? This actually says that whenever you communicate actual, real, honest data in a very deceptive manner. So you have actually started off with really true data, but then when you communicate this data, okay, you do it in a certain deceptive manner, which actually hides the real nature of the data. And why do you do this? You do it only to get your publication through. But this, mind you, here you are not fabricating data, here you are not falsifying the data, and you're not plagiarizing any data. It's really true data, honestly taken in an experimental situation. But the interpretation part is not correct. So you are misinterpreting the data by giving it some spin or something so as to make it acceptable as a publication. So that means this is not really a scientific misconduct as drastic as the other three, that is the FFP. So this falls in the middle gray area, which I had referred to in one of my talks earlier. So we had the absolutely white zone and the black zone and a gray zone in between. So this kind of data misinterpretation, it actually fails to convey an honest interpretation of data and thereby creates a false impression to the reader. Okay, so it makes one's results appear more significant or convincing than they actually really are. And they also draw unwarranted inference from the data, and they also use suggestive language for rhetorical effect. So these are the various types of common misuse of statistics. So how do you do this? You can truncate an axis and show a different form of the data, or you can do some cherry picking, only take that part of the data which is relevant to your hypothesis, or you can use a percentage change in combination with a very small sample size, which is not correct. So there are various other ways: misleading data, visualization, flawed correlations, faulty polling, etc. Okay, so these are the very various common types of misuse of statistics. Here I show you how you can actually misinterpret data. In fact, this data is my own data. I'm just showing it to you how it can be uh, uh, misrepresented. So you can see that this is a certain function as a function of angle. We have some full width at half maximum of some reflections as a function of 2 theta. This is a diffraction experiment, which we actually found out the full width at half maximum of the diffraction peaks and then plotted them as a function of 2 theta. So here you can see that the actual data, it varies from roughly about 0.28 to about 0.3, 0.37 or something like that. Okay, this is how much, half of this, or 0.375. Okay, so this is the actual variation of data. But suppose I don't like that to see this sharp fall like this, because it is not matching, suppose, with the text which I'm writing to describe this data. So I would like to use a text which says that it is almost flat. So what do? I simply increase the y-axis to a higher value, and automatically this appears slightly shallower. I can do that even more and even not show it. Okay, and you can see that the variation is very negligible. I feel that variation is very negligible. So actually, whether this variation is negligible or not depends on what physics you are talking about, what is the experiment you are talking about. Okay, that is the main thing. But to visually convey that there is no variation, okay, you just simply increase the value of the limits of the axis, and they show an erroneously a false way of showing that this is the variation. Of course, an intelligent person will definitely look at the axis and then say that this and this are the same. Okay, but this is how one can actually fool people and say that you have achieved a different kind of a result. Okay, there's another very interesting variation which is concerning global warming. So this graph actually shows the global air temperature change in Celsius. So what this person has shown here is the data from 1998 to 2012, and he says that actually the global air temperature has decreased with time. Okay, so this actually supports the view that whatever people are talking about global warming is all hoax. That's what the earlier president of the United States was saying, that global warming is a big hoax. Okay, so probably he showed this kind of a graph and says that, look, we are actually having a reduction in temperature. But what are you concealing here? You are taking a very small data point time variation here. So now if you see the same thing with an increased, with an increased time from 1980 to 2012, now you can see the situation. See how the graph goes up from 0.2 to almost 0.58 or something like that. So it paints a much better picture of global warming. In reality, if you really want to see how the global warming is taking place, you actually look at the data right from 1900, and this really shows you a true picture of how global warming is occurring. So you just have to fool with the axis and then show data in a totally different way. Okay. And there is another very popular advertisement by this very famous company KFC. It shows that the number of calories in their product, chicken twister or something, they say that we have just 650 calories compared to whatever the Burger King or whatever the other company is giving you. So by looking at this data at first glance, it appears that the KFC's product has half the number of calories of the other company. But in reality, what they have done is they have started the graph from 590 and not 0. So if the graph starts from 0, you can easily see that this has no meaning at all. It is hardly any difference. So, but this is the way people try to fool and misinterpret data to convey something else which they want to say. So how can we actually prevent scientific misconduct? We talked a lot about various kinds of scientific misconducts and things like that. So how can you prevent, what are the steps one can take to prevent scientific misconduct? This has been debated by a number of people, and there are several approaches which have been given to correct this scientific misconduct. The problem is this is widespread and so prevalent everywhere that no one guideline or something like that or rule is going to prevent this kind of scientific misconduct from happening. Because scientific misconduct emanates from people. Okay? It is not emanating from your experiment. Scientific misconduct emanates from people. That's where the philosophy and ethics come into play here. Okay? So, as I said, scientific misconduct can vary from very honest errors to outright fraud, and this happens in a continuous manner. There is no sharp division between what is ethical scientific behavior and what is non-ethical scientific. So, the scientific institutions and the science managers, they must take a heavier responsibility for ensuring ethical research environments as well as research practices, and thereby avoid minor breaches of good scientific conduct. Then the research community itself, they must take a collective responsibility even for its deviants. That is, people who deviate from scientific, correct scientific conduct. The research community as a whole must take a collective responsibility because it is happening within the system itself. If you look at the whole research community as one big entity, it is happening within the system itself. So the whole research community in principle has to take collective responsibility. Then again, regular seminars and courses, probably like one of these, must be organized on the causes of scientific misconduct, what are the outcomes, and what are the consequences of scientific misconduct. Then we have this big three frauds, that is fabrication, falsification, and plagiarism. They should have a very strict definition so that whoever indulges in these kind of misconducts can be acted upon even legally. And while for less culpable misdemeanors, like misinterpretation, for example, so you need not have a very stringent penalty, but even something like a warnings or something like that should be fairly enough, depending, of course, on the amount of consequence it has generated. Then the current guidelines and regulations, they should be simplified and made readily available to researchers. See, if the researchers don't know about these guidelines and regulations, there's no point again. And then education. Research training must include ethical and legal issues. And when young students, especially those who may not know about all these issues, they must be taught about these things, and the supervisors must somehow see to it that the students are made well aware of all this kind of misconducts and must be informed what is good scientific behavior. Then we have effective and independent mechanisms we must have for investigation of suspected incidents of serious scientific misconduct. And these should be set up at all in all countries at a national level. And also simultaneously, you must also protect people who are the whistleblowers. That means people who bring scientific misconduct before, so they should not be at the receiving end. Like we have seen in earlier some of the cases I described, people who have been who brought out the scientific misconduct, either they were terminated, their fellowships were terminated, they were asked to go, they were asked to leave, or if there happens to be a faculty member, they were suspended, and all these things happen. Okay, so they must be protected. So there has to be a mechanism which takes care of this. So if one can simply reduce emphasis on productivity and the number of publications, okay, you can really have a more healthy culture of transparency, and culture of transparency and ethics can be established. Okay, then we move on to the last part of the lecture today, the ethical issues and ethical committees. So the ethical committees, at least in India, every institution, of course, now has ethical committees, which basically look into scientific misconduct. But there are also institutions which deal with human beings as well as animals as part of the research activity. Like, for example, if a new drug is discovered by someone or some company, they have to. You have seen this the recent incidents of vaccine for COVID-19. It's so difficult to obtain the vaccine because one has to do certain trials for validating the vaccine. So one has to test it on a big enough sample size to study whether the vaccine gives you any after effects or things like that, whether it is safe or not. So all these things have to be carried out before any drug or a vaccine comes out into the market. So in India, like what we have, the FDA, Federal Drugs Agency in the United States, in India we have what is called the Central Drugs Standards Control Organization under the Government of India. So they have certain, they have framed certain guidelines. So as per the drugs and cosmetic rules, every research institution or organization dealing with human subjects is required to form an ethics committee, which has to be registered and must follow the guidelines issued by the CDSCO. Now, what is this committee? Ethics committee is a committee comprising medical, scientific, non-medical, and non-scientific members. One of them has to be at least a legal expert, whose responsibility is to ensure the protection of the rights, safety, and well-being of human subjects involved in a clinical trial, and it shall be responsible for reviewing and approving the protocol, the suitability of the investigators, facilities, methods, and adequacy of information to be used for obtaining and documenting informed consent of the study subjects, and adequacy of confidentiality safeguards. And in the case of any serious adverse event occurring to the clinical trial subjects during the clinical trial, the ethics committee shall analyze and forward its opinion as per the procedure specified by the CDSCO. So there are several such guidelines and rules, and also the ethics committee must allow, ethics committee of that particular institution, they must allow the inspectors or officials who are authorized by the CDSCO to enter its premises to inspect any record, data, or any document related to clinical trial and provide adequate replies to any query raised by such inspectors or officials as the case may be in relation to the conduct of the clinical trial. So this you can see in relation with the example which I told you of the antidepressant example. So the data, for example, the trial data has to be deposited with this organization like CDSCO or the FDA in the United States. So they have all the original data. So immaterial of what publications come out of it or what happens down the line in time, okay, the original data has to be deposited with these bodies. So at any time, one has to go back and check what actually happened in the original trials and can draw upon this data and then work out what could be the future ways of doing corrections, etc. And then if this ethics committee fails to comply with any of these conditions of registration, the licensing authority may, after giving an opportunity to show cause why such an order should not be passed, by an order in writing stating the reasons thereof, suspend or cancel the registration of the ethics committee for such period as considered necessary. So that means ethics committees have a very big responsibility in any organization. For example, in the Bhabha Atomic Research Center, we have what is called a medical ethics committee, which also has obtained its registration from the same CDSCO, and they have to conform to their guidelines and regulations as they should time to time. So every institution which deals with biomedical research must have this kind of ethical committees. Apart from, of course, the other ethical committees, ethics committees for cases of scientific misconduct and things. These are more important because they deal with human lives. And of course, sometimes they also deal with animals. We have very similar guidelines for ethics committees, which deal with prevention of cruelty to animals and things like that. So these are some of the things which concern ethical committees. So I think with this, okay, one last point is about ethics and the environment. See, there are also ethics concerning environment research. The environmental ethics, they deal with issues which are related to rights of individuals that are fundamental to life and well-being. So we have certain guidelines under environmental ethics, like resource consumption patterns and a need for equitable utilization. What this concerns with is basically we get our resources from the earth, and then we consume these resources. Sometimes it so happens that people living in a certain part of the world consume more resources than other parts. So sometimes there is an inequitable distribution of consumption. So there is a need for equitable utilization. Then equity disparity in northern and southern countries. This is also well known, where most of the northern countries are part of the Western world, and southern countries are part of the third world, mostly African countries and things like that. So one knows very well what is the disparity between these countries. And then urban and rural equity issues. Again, like the environmental concerns of a rural environment and an urban environment are quite different. And one has to understand, each has to understand the other's concerns. Then preserving resources for future generation. See, if you use up all the resources now, there will not be anything left for future generations. So there has to be certain care and ethics involved in preserving and utilizing resources for future generations. Then rights of animals. See, animals have equal right to live as human beings, and especially when you look at the forest, depletion of forests, like depletion of animal species, tigers, for example. So at one time, we had just 200 tigers left in India. Now the situation is slightly better, but then they are still endangered. So animals have also a right to live. Then ethical basis of environment education and awareness, which must be like in every schools, etc., education institutions, people must be made aware about environment and the pros, the problems which are dogging the environmental situation these days. Then finally, of course, we have conservation ethics and traditional value systems of India. Like if you go and see, especially in the rural areas, there's a lot of traditional value systems, which if only they are adopted even in the urban areas, it will matter a lot. So this is something on environmental impact of ethics, and this is also a part of the this particular course. So I think with this, I come to end of today's lecture. Thank you very much. Please let me know if you have any questions. This is a comment here. Sometimes misleading in trend prediction until the error bars are shown properly. Uh, is this a part of the question or is the entire question? Can I see the chat box? Presenting the average values on a graph are sometimes misleading in trend prediction until the error bars are shown properly. Absolutely correct. So it is very important that you must show experimental error bars in any graph which you show in the in any scientific data. That's absolutely correct. Yeah. Any other? The other side. Well, there don't seem to be any more questions. So, yes, that's it. Thank you very much. Let's meet again on Wednesday.